Good. All right. I can't see myself, but I can see my slides. So, all right. So I'm going to touch on the Universal Secure Loader, an idea I've had for a while. It's actually, I'll dive into the details, but just real quick introduction to myself for those that don't know me. I've been around for quite a while. Been involved with a lot of different things as far as virtualization and security goes. Run my own little company here, working on all this information and projects. So no need. That's a good summary of me at this point. So the Universal Secure Loader kind of was what was originally envisioned when I started Trench Boot, and that's what kind of guided the architecture that we have here. And I'm not going to go over all the details, but some have seen this slide before or seen this diagram before. But basically, when we look at the way a system starts, there's really kind of three phases, or well, two existing phases, which is the bootstrap phase and then your runtime phase. And the Trench Boot architecture was kind of to introduce an intermediate phase in between these where we can use DRTM to launch the system. And in that, we came up with this idea of the Trench Boot loader that had contained inside of it a security engine that would do any kind of evaluation from what the DRTM might have measured. That could be anything from just taking the measurements to actually doing unsealing actions to doing remote attestation. That was kind of the larger vision of what could be done. And we kept it very generic this way before narrowing down into a specific implementation. So as I said, we try to keep it generic so that you could use multiple design patterns at this. We kept it independent of the system loader, and thus you could do this intermediate loader kind of use case that we're going to be focusing on today. You could even just make it a function of the OS runtime startup code itself. And so if you look at that previous diagram, the whole runtime phase, the target runtime and the intermediate phase could all be thought of as being part of the OS kernel. So that was the approach we took, and then to allow this kind of flexibility with the approach. And then the Universal Secure Loader itself was an implementation of the intermediate loader pattern. And this is what, in conjunction with Oracle, this is what we've been working on all this time, is to build an intermediate loader for Oracle's cloud platform. So basically what the intermediate loader design pattern is exactly similar to what Microsoft also uses. So if you're familiar with how Microsoft uses DRTM in their system, their WinLoad bootloader actually does the DRTM into a separate intermediate loader that is used to then start the final system, whether it's the Windows hypervisor or just the straight Windows kernel. So keeping with that design pattern, that's, or I'm sorry, let me touch on the Trusted Boot or T-Boot as an intermediate loader, just as a stop here. So a lot of people think that T-Boot is an intermediate loader, and that's only partly true. And that, that kind of derives from what they describe themselves at. But if you actually look at T-Boot itself, it actually follows an exokernel panel design pattern, where T-Boot itself always remains in memory and is responsible for managing ACPI states. And then an OS kernel has to be enlightened to interact with T-Boot to actually trigger any of those API power state changes. Now we can dive into actual the USL, or the Universal Secure Loader. So just like how Microsoft has their unified loader, and to some degree how T-Boot does it, the Universal Secure Loader was basically meant to handle the DRTM event internally and then launch your final system. And the idea is that we can be able to accomplish this on even UEFI platforms, and that's the hope. But obviously, UEFI always causes wrinkles. So this gets us to the internal design of what that actually what was put together to make that all happen. So the first component was actually Grub. So we make Grub aware of how to do the DRTM. As far as USL goes and what we're extracting out and making a standalone project now, you could actually implement any bootloader you wanted to handle the DCE preamble part of the phase, which is the setup for the DRTM. But for now, we have Grub that does that. And then we're taking advantage of Grub's ability to package a mem disk inside of it to contain whatever you want to package along with Grub. So in this case, we actually package the dynamic launch measured environment, any optional RAM disk needed by that, and the dynamic configuration environment. So those are the TCG names for those items. What that basically breaks down in terms of internal components as we're building it today. The DLME is the Linux kernel with the Linux secure launch. The optional RAM disk is the uroot project, which has been used by Core Boot and Linux Boot for being a bootloader payload. We worked with them and we actually incorporated some of that of secure launch logic into that. So that's already upstream and available. And then the DCE for on Intel platforms is the SNet ACM. When we incorporate AMD onto this would be Trench Boot's secure kernel loader, or the SKL. So I kind of went through those components. The anything here. So yeah, I already covered all the components here. The other aspect of USL is the build system that allows you to generate these binaries. So while, in conjunction with Oracle, we built all these components for them for their use internally. The fact is that other individuals might want a different payloads and different capabilities loaded into it. So really at the heart of all of this is a build system that allows you to build this standalone binary with your own customizations in it to do a DRTM launch of your kernel. I'm not going to go too detail on the build system, but this kind of gives you an outline of what it is. Just a set of scripts that can build within a container or right directly on your desktop that will build the components, package it into the mem disk for you, and then generate a single binary. Once you have that binary, you then will be used. Like I said, we use the uroot capability, which has the SL unit capability that we upstream to uroot. That actually looks at your at all possible drives available, and then it will looking for a policy file, or it can be you can tell it where to look for it via a command line, kernel command line parameter. And in this policy file, it actually allows you to control what you want USL to measure on your target system. The capabilities we put in there for Oracle's need include being able to read DMI and measuring any aspect of the DMI information, so the SM BIOS information. It will actually measure parts of the CPU ID fields. It will measure a file on any disk that it can has the file system to mount, including network devices. It has the capability of measuring entire block devices, and that's most of the measurement utilities we put in it today. As a result of that, it actually captures the DRTM log and then writes it to the disk. That's provided by another configuration parameter. And then the last part of the configuration is telling it what you want to boot and what method you need to boot it. And that takes advantage of all of the work that was already done by uroot in terms of their capability called system boot. It allows you to basically do Linux, multi-boot 2. I think I don't know if there's any other boot protocols out there, or if they have it in there, but they've done a lot of work there to enable that. And there's a link here that will take you through the exact all the parameters and how you set them for the policy file. The current state, so the build system is working. We can do binary, we can generate the binaries, and um, the next step is to get that in an automated CI so that in the project page we can then publish at least the base images available for anybody just to download and use. Um, Currently, we only have Intel TXT supported with it. We're only building for TXT right now. Um, the next steps that we need to get incorporated in there, while System Boot already has multi-boot support in it, we just have to make SLNet uh, aware of setting up the multi-boot. There, we also need to start. We're tracking the changes in the Trench Boot Secure Launch Protocol. So as that stabilizes, that'll allow USL to finally stabilize, and we can start um, getting more images out there. Moving forward, right now, as we start to get some images out there, we want to get some volunteers to CI test. This will help us, the Trench Boot overall. Right now, there's very limited platforms that Trench Boot's getting tested on. Oracle primarily focuses on server, and Cube or 3M Dev is working with cubes, and they're integrating it on a very specific set of devices for cubes. So the more devices we can get, the patch series is for Linux and Grub exercise, the better. So we can determine that or make sure that it's all working as smoothly as we think it is. And then as people are doing that, that allows us to collect bug reports against the existing Trench Boot capabilities and help build up a better hardware compatibility list for Trench Boot. I haven't put the project page out there yet. I was meaning to do that today, but the day got away from me. But that should be up by the end of the week. It's here. And then in terms of a larger roadmap of where we're going to take all of this, we're going to continue refining USL, expand its build system, and hopefully make it much easier for people to be able to just use the dynamic launch capability. Linux distros should be able to incorporate this easily and get into their distros once we've got a lot of this stabilized. People that just want to tinker and play around and expand capabilities, it'll give them a framework to generate a single binary that they with their customizations in it that they can test with. So that gives us the target user base of just your home users, your enterprises, and even there's the possibility that vendors and supply chains could start to look to adopt this. And then yet again, one of the things that's bitten me recently is just dealing with UEFI. It's the gift that keeps on giving. So that's just kind of where we're going with it. Now, just to help give some idea of how it can be used by any of these individuals besides just playing with it. One of the methods that was used by Oracle, which we briefed at, I did a joint presentation back at FOSDEM 2021, was the introduction of having two different bootable MLE environments. One being the one that's used to start up the system, and then one that's actually done for a management MLE or a management upgrade image. So what that does is you'll have a single binary that's actually could be kexec from your running system that would basically dynamically launch into an environment that's capable of upgrading your system and doing so in a way that it forward seals the PCRs to the new configuration. That way, once it's done and reboots, the system will boot back up, and if you're using TPM seals to seal keys, those keys would actually be unsealed, and you wouldn't have to deal with a measurement mismatch after upgrade. And then there's certain, depending on what your security profile is on it, the way it was done for the talk, the MLE didn't actually have network access. So we blocked all IOMU all DMA, and we did not use a kernel that had network drivers in there. So there was no way for any interaction with the upgrade kernel while it was upgrading the system. But that can always be tailored to people's desires. And if you ever want to, there's the link to there if you want to go listen to our talk about this and get more details on how that would be done. Another usage of this would be from an enterprise integration standpoint would be a supply chain integrity. So you can then build on that same kind of management MLE, boot MLE kind of concept, and you can actually have a loader that can do that you can extend to do blockchain validation of the platforms if that's of concern. And these kind of attestations against blockchain could actually be used by a client device to decide whether or not it should be allowed to connect into the provider's services, or an enterprise can decide whether it's allowed to get onto the system of depending on what its blockchain looks like. So those are kind of the examples that I gave. Unfortunately, I didn't have a demo today because, as I said, UEFI kind of bit me a little bit. But in totality, the key thing that you gain with USL here is the build system, right? And that is the big gain that everybody will get from this. While we can generate standalone images that people can just download and play with, the key point here is that we have a framework that can be used not only for adoption, but allows for us to do tests of the Trench Boot project. Anything else? That's it for the most part, and I think I'm over by a little bit. So at this point, we can go into Q&A.